name is Villanueva. I am a PhD candidate at Purdue University. Today I will be presenting RobotAR, an augmented reality compatible Teleconsulting Robotics Toolkit for augmented makerspace experiences. So what is RobotAR? It's a desktop-based Teleconsulting Robotics Toolkit to create augmented makerspace experiences. Teleconsulting robots can be used to bring the instructor into the student's workspace. So if we can combine the teleconsulting experience with AR technology at student homes, we can make it easier for instructors to diagnose the problem. This last year, due to the pandemic, there has been a huge experiment in virtual classes, but these often led to multitasking and distraction and left students feeling frustrated and fatigued and complaining. And this problem has been diagnosed as the creation of Zoom zombies. In this new paradigm, the success of distance learning depends on mimicking face-to-face instruction as close as possible. So here is a quick preview of what our teleconsulting robot looks like. The robot has mechanical wheels which move in any direction and a 3D printed adjustable holder to mount the phone onto and pair it with the Bluetooth module. The microprocessor controls the behavior of the robot from the Bluetooth module, which signals track the electric motors. The network architecture was built to have the phone transmit the live video feed to the instructor's computer and allow it to receive the virtual instructions and robot commands. We use the cloud-based framework with AI, which processes each student's utterance in a remote server, identifies student's intent, and is sent back to the phone. So to set up, students set the boundaries of their workspace to pick the initial locations for the robot until instruction begins. Then instructors can also add several AR animations to introduce concepts to students, like a pre-lab. In standby, when the robot is idle, the student can either ask the AI assistant directly or enter the teleconsulting mode. And during teleconsulting, the instructor can assist students. In the instructor's UI, the instructor can teleconsult with students and operate the robot by moving and tilting the angle of the phone holder, and then the instructor can add AR animations and AR content in the form of lines, arrows, text, and send live demos. So here we have a sample of what the teleconsulting with RobotAR looks like. On the left side, the student is showing her work and asking a question, and on the right side, we have the instructor providing help in real time. We performed a user study with 24 participants and split them into two conditions, Zoom video conferencing and RobotAR, a full implementation of our toolkit. Each session was split into a lecture part and hands-on making. We chose a crash course introductory lesson on basic electrical circuitry for our testing. The three-part series included the following topics: using basic tools, connections in series and parallel, and transistors and capacitors. We tested the students using pre- and post-tests, and we observed statistically significant improvement in 6 out of the 7 key competencies we evaluated them on. So the use of RobotAR improved the following key competencies: understanding of voltage and current, connections in series and parallel, circuitry, use of breadboard, measurements, and finally having a working circuit. Also, in the Zoom condition, only 3 out of the 12 students managed to complete all the exercises available. Meanwhile, 7 out of the 12 students from the RobotAR condition managed to complete theirs. Similarly, using RobotAR, the self-reported results indicated an improvement in management by instructor, awareness of instructor, teleconsulting experience, useful aid, instructor presence, and voice and visual aid from the system. So here are some highlights from those user studies. AR content, which could be replayed, and the real-time annotations and drawings from the instructor were crucial to improve the key competencies for students. The instructors also reported that they were able to provide more on-point instruction. This was because as they manipulated the robot, then they knew where to focus because they intuitively knew where and what they were looking for. So this allowed for higher quality of teleconsulting. So to close on this project, I want to leave these key points. RobotAR is a robotics toolkit to provide AR makerspace experiences, and our toolkit was a great tool for instructors to check in on students in 2 ways: quick checkups of students' progress and providing higher quality instruction without interrupting students or asking them to do all tasks as cameramen. These prove that giving instructors full access to students' workspace enables 2 times higher completion rate, 23% improvement in overall learning gains, and 30% decrease in average teleconsulting time. Thank you very much.